So exercise related to standing wave. The first 32 questions are already being solved. So we'll start with 32. So you will have an idea that how to solve such questions in exam. So here in 2010, the Football World Cup, which was held in South Africa, for the noise which is produced by this pipe instrument. The first question is, as I mentioned, is explain how standing wave is produced. So how standing wave is produced, you have to learn the structure answer for this. Remember, first thing you will say two waves traveling in opposite direction. That is one mark. They will superimpose or superposition occur, or they will combine with each other, but better term is superposition. That will score the second mark. And it will produce a points where in phase, that is antinode, and anti-phase, it will produce nodes. So how you score the 3 marks? First, two progressive waves moving in opposite directions. Superposition happen, and it will produce nodes and antinodes. Nodes are the points which are due to antiphase combination, and antinodes are the points in which they are in phase. The particles, when they combine, they are the interference or a combination is due to the particles which are in phase. So node means the zero amplitude points and antinode means the maximum amplitude points. So this is always a structured answer for explaining how the standing wave is produced. Then the diagram shows a standing wave. This is an open pipe, as you can see, open, and we have antinode, we have node, and we have antinode. Calculate the frequency. If we need the frequency, we have the formula V equals F lambda. So if frequency is there, frequency will be speed divided by wavelength. We have the speed, we have V. How to work out the wavelength? The length of the pipe is given. The length of the pipe is 60 centimeter. But SI unit of a length is meter, so we divide it by 100. So it will be 0.6 meters. Now, what is the wavelength in terms of the length? Because the distance from node to antinode is a quarter of the wavelength. And distance between the two successive antinodes is equals to half of wavelength. Like from here till this point, it is quarter. And node to antinode, again, it is quarter. So this total distance, quarter plus quarter, so it will become half of wavelength. So L is equals to half of the wavelength. If we need the wavelength, that will be equals to 2L. So the wavelength will be equals to twice the length. So 2 multiplied by L, which is 0.6. So it will be 1.2. So the wavelength is equals to 1.2 meters. So we have the wavelength and we have the speed. We can work out the frequency. Frequency in this case is a speed divided by wavelength. Speed is given 330 and the wavelength is 1.2. So the frequency will be 275 hertz. Is it clear? This part B. Then Standing wave, the human speech contain a continuous range of frequency. Like as we speak, we are not producing a single frequency, we are producing multiple frequencies. So this sound is analyzed and found contain only a certain fixed frequency can be heard by the human. Like F1, F2, F3, F4, these are different frequencies. At the football World Cup, the noise of this instrument, it is difficult for a television commentator to be heard. A solution was used. A solution was to use a filter that removes some frequencies to produce. Suggest two frequencies that would be the best to remove the effect. And will be the disadvantage of removing all the frequencies? Like it was producing multiple frequencies were there, but the drawback of this that it was difficult for the television commentator to be heard. Like it was so noisy that the commentators sound was not clear. So which frequencies we should remove and why? So which frequencies which should, this is the amplitude, the loudness. So if we remove the louder one, like example, F3 is louder and F2 is louder, these are the louder frequencies. So if we remove them, that will reduce the noise level. So we should remove the frequency F2 and F3, and why we should remove them? That will reduce the noise level. And what will be the disadvantage of removing all the frequencies? So if we remove all the frequencies, like if we filter all the frequencies, then what might happen? Maybe some of the frequencies are for commentators as well. So that frequencies will also be removed because they asked this question. The question is like which frequencies we should remove. State two frequencies that would be best to remove, and effect would have, what will the effect it will have? Like if we remove these frequencies, so it reduce the noise level. But what is the disadvantage of removing all the frequencies? So if we remove or filter all the frequencies, then the commentator frequency might also be removed. Like a commentator, he's producing different frequencies as well. So his frequency will also be filtered off. So the frequency which we remove, that is F2 and F3. And why we should remove? Because they have the highest amplitude or they are louder. And what is the advantage? It will reduce the noise level. And why not all the frequencies are removed? So if you remove all the frequency, it will remove the commentator frequency as well. So that will be a disadvantage. A noise cancellation headphone work for detecting a sound and produce another sound in antiphase. So it causes a destructive interference. What is meant by antiphase and a destructive interference? These are the definitions you have to learn. Antiphase, the term antiphase means when two waves are there, the angle, well, like when they're 180 out of phase, like two waves combining, and they're 180 out of phase, we call them as antiphase. Like one wave is 180 cycle out of phase with another wave, we call antiphase. And what is a destructive interference? When two waves cancel out the effect of each other, or it will produce a zero amplitude or a zero intensity wave, we call that as destructive interference. So antiphase means the two waves, or you can say one wave is 180 out of cycle compared to other wave. That is the definition of antiphase. And what is the destructive interference? The two waves cancel the effect of each other. When two waves cancel out the effect of each other, we call that as destructive interference. constructive when they increase the effect. Explained why the headphone could not be used. Look, noise cancellation headphone produce can are useful to cancel the sound with a certain frequency. It's not like noise cancellation headphone are useful for canceling out different multiple frequencies, because it has to produce multiple frequencies to cancel out the sound. Frequency one, frequency two, different frequencies are there, seven different frequencies. So noise cancellation work when there is a certain frequency or a fixed frequency and a certain amplitude is there. But even these frequencies have variable amplitudes. So that's why the noise cancellation headphone will not work here. Why it will not work? Because one thing, like amplitude of a noise is not constant. Like sometime the noise level is much higher, sometime the noise level is lower. Noise cancellation headphone it work best when we have a constant frequency, or a a frequency and a constant amplitude is there. Like usually at the airport on the runway, those who are involved in technical, like the technical stuff, they have these noise cancellation headphones because the sound produced by the engine is having a constant frequency and amplitude. So it will be much more easy to cancel out that sound. But for a normal speech, the noise cancellation headphone, it won't work effectively as there are multiple frequencies are produced and a different amplitude. So it will not work because the amplitude of the sound is not constant. So this was question 32 from the standing wave assignment.